What are the first 10 things you would do on a new AWS account? We are going to detail that. Stay tuned. Good morning, good afternoon. Thank you for downloading the AWS Developers Podcast. We're available on all good podcast applications, YouTube, Deezer, Spotify, Apple Podcasts, and probably many others as well. Available on the web as well. Today I have a special guest, Cobus Bernard, your developer advocate, maybe listeners of the podcast knows your face already because we can see you a lot on videos, on Twitch, on YouTube as well. He's one of the big guy with a bird. There is Darko and Cobus, so you're Cobus, that's correct?
Well, for today at least I am. Maybe tomorrow I'll be Darko again.
Or you can pretend to. You recently wrote a very interesting blog post, and the link is in the notes of this episode. Of course, you can scroll down and click on the link. What are the first 10 things you would do for a new AWS account? And I think it's worth going through that because you built some interesting automation as well to secure your account. But why?
Why?
First, you have 14 years of experience with AWS, so you are used to manage accounts at scale as well. First, why are you still creating new AWS accounts?
Basically, this all came about from me cleaning up the mess that I have with my personal accounts. So, for context, my personal account's set up. I think I've got about 8 different accounts, and some of them, like one of them, I created way back in 2010 when I did the first bit of AWS work, and then kind of forgot about that account. And because my background is as a software developer and then went into DevOps and automating things, I decided, hey, I'm going to start cleaning things up. And then during that cleaning up, I discovered a bunch of things that, weren't supposed to be there, and that I did badly. And I just want to say, okay, cool. Well, if I now start a new AWS account, how would I do it in a nice, clean way with what I feel are the things that should apply to pretty much everybody? Because it is a hot topic, because when you start saying these are the things you need for a new AWS account, you always have to add in the part that says, okay, what is your organization's needs? Do you need, for example, a full built-out landing zone with federated users into Active Directory? Well, yes, there are a lot of people that need that, but I don't think everybody needs that. So what I try to do is saying, listen, after building on AWS so long, helping companies on board, cleaning up accounts, what are the main things I think would be? And I try to reduce it down as much as possible to things that I would say apply to everybody.
Why are you creating multiple accounts as an individual user? For enterprise, I understand you need a development environment, a test environment, production, maybe all 3 per application. So you multiplicate your AWS accounts with customers with hundreds or thousands of accounts. But as an individual software developer,
why? Okay.
Why?
Yeah. So from basically perspective of managing things, the way I view it is that I've got what I call my top level account, which is a billing account. And what that AWS account is, it hosts basically federated billing into every single child account that I set up. So there's one place that I can look for my payment details, to look at all the bills, see exactly how it's broken down per account. And basically I try to do nothing in that account, because the whole purpose is that's the top level entry point.
That's the management account.
Yeah. Exactly. Mm-hmm. It's one of those, I really don't want to touch that account unless I really need to, and I know that everything's in there. Then the second account that I did was, I'm one of those developers that has way too many domains as well. And a while back I had them across, I think, 4 or 5 different registrars, and it became a nightmare, especially when I moved to the US, to clean up all the details about account ownership, your address, all of those things. So I went through a period where I said, okay, cool. If I want to go clean up my DNS, how would I do it? And in general, you don't want to have your registrar configuration right next to your DNS actual configuration as well, because you make changes to DNS often, but you shouldn't make changes to your registrar that often. And obviously, if someone gains access to the registrar page to manage it, they can transfer the domain away, and then guess what? Your domain's gone. Mm-hmm. So my approach there is saying I've got one AWS account just for the registration of DNS. So I migrated all of them into that one account. And then I've got a third account that is just for my DNS zones. So in there, I basically set up my Route 53 zones for all the different domains and manage my DNS there, which means that I still have the centralized single place to manage and add new domains as I have random ideas. but it's separate from my actual DNS config. So there's a implicit layer there where you can't jump from one to the other, even though with my multi-account setup, it's not 100% true, but it's close enough with how I set it up.
So you're really applying the separation of duties to the maximum. One account for the DNS register, one for the DNS setup itself, one for the billing and the management, and then probably several for testing different IDs or different projects.
Well, yeah, then what I've got, because I prefer multi-account setup for anything that like application that I build. So I normally have a central account for that. I call that the main account, that's where you have your build pipelines, your artifacts, your central things that span multiple environments. Then I've got a dev environment account, then I've got a production environment account, so I can do staggered rollouts and test between the two, make sure that the infrastructure stays in place and play with it. And then I used to do consulting back in South Africa, so for that I had a registered company that I used for sending invoices and managing it. That also had obviously a DNS domain to manage, so in there I had a bit of config, so that's another separate account just for the business stuff that I had to do.
For the company.
And then I recently added my personal account from 2010 back into this organization as well, because I have the account. I still need to go look exactly what I'm running in there. I don't think there's anything on anymore, but it's just I have the account. I don't want to close it at this point, so let's just add it in and manage it, and I'll figure out what I want to do with it later.
So now I understand why you open so many accounts and you need to automate that. You're not making your life easy, because having a deployment pipeline across multiple accounts, it's not easy to configure. It's much easier for personal usage, demo, to have everything in one account, no?
See, that's where I want to disagree with you. And that's one of the things that I really like about using Terraform with that, because with Terraform, what you can do is when you configure your credential or your AWS provider, you can configure multiple of them. So I can have the main provider, which is, let's say, my main account, and then I can define a second provider called, let's say, my DNS account. So, and I just call it AWS.DNS as a name, and I tell it what IAM role to assume. And that IAM role is actually, what AWS CLI credential profile.
So,
so I configure my profile with the AWS CLI, and then in Terraform I just say, well, you're using the DNS account. So it's literally 4 lines to do that. And then what I do is, if I want to create, let's say, a DNS zone, and I want to use that account, there's one line that you say provider equals AWS.DNS in Terraform, and then Terraform knows, hey, that implies a different configuration. It goes and looks at the config in my AWS CLI config file, and then knows how to do the role switching. So I still only have one pipeline that is able to jump between all of these accounts and manage all the resources for me in one go. So it's actually very simple.
But it's managed by Terraform. Okay.
Yes.
So what are these 10 things you do when you're in an org? You say new account, and then what?
Okay. So first one is always remove the any API keys or things for the root user and add multi-factor authentication.
On the root user itself.
Yes, because the root users, if you're inside an account with a root user, you've got full access, and there's nothing blocking you from doing anything in that account. So that's why the security best practice is to try and get away from using your root user as quickly as possible. So what I did with this approach is saying, like, okay, you've got a new account, there are a couple of things you have to set up, but it's kind of this chicken and egg problem where you don't want to use the root user, but you need the root user to set up users to then set up things. So basically, let's go through how do I go and get everything going, and then walk away from the root user and forget that it exists until I need it one day.
So the first thing, you activate multi-factor authentication on the root user for the time it needs, or you need root credentials. After that, you can remove the root credentials altogether and never access the root user anymore. By the way, we released a few weeks ago, it was before reInvent, a new capability in IAM that allows to centrally manage root user credentials for all the accounts in an organization. Did you switch to that new capability already? Or that's something you're looking at?
I still need to go. I still want to go play with it and actually just make sure, because part of my cleaning up of all my old or all my AWS accounts was I had to log into every single root user to go and change the billing details and the countries registered in and the tax forms. Because, like I said, I moved from South Africa to the US. Obviously, there are tax changes that you need to apply for that. But I still need to. I'm definitely going to use that to go delete all of those root user details. So I would have to follow a full password reset if I ever want to access them.
Second thing is to get some visibility on the budget, on the cost.
Yes. Yeah, so there are two there. I'm just going to jump between 2 and 4 now. So the first one is the Cost Explorer, which when you've got a new account, you just have to navigate to that page the first time, and then it takes 24 hours for them to start collecting the information and show you the graphs, and you're able to drill down. And that basically allows you to go say, listen, in my account across all the regions, how do I want to slice and dice and look at where money is being spent? Because especially with me having accounts this old and having played with random things over the years, I honestly at this point can't remember when I clicked on what. Because obviously, well, not obviously, but I started building on AWS before I did infrastructure as code and automation, where I actually know where everything is. So that's a nice way to go look and see what is running where. You see, like, let's say a random 2-cent line item on your bill, and you kind of go like, well, 2 cents is not that much, but how do I go find what it is? Well, now you can, because this will give you the full breakdown. You can go by region, you can go by service, slice and dice, have a look. And then the second one that's part of that is the cost optimization hub, because with that it also needs to have data to be able to figure out what's your baseline load, make recommendations for like downsizing or upsizing instances. So, and it doesn't have any inherent cost just to enable it. So that's why I would like to have that, because I know at some point, when you've got a new account, you're probably going to first focus on, can I build it? Can I get it up and running? Is it working? And then you start going to go, okay, cool. Now it's stable. It's working. Let's start looking at optimizing the cost. Let's start looking at monitoring. It's kind of like that standard flow of building something new.
So what are you doing in terms of Cost Explorer and cost optimization? Is it enable them? That's something,
yes.
It's not enabled by default?
No. So they're not enabled by default, and that's why, like I said, for Cost Explorer, it's literally open the link once and you're fine. With Cost Optimization Hub, there's a setting you can do. And it's one of those fun things where you can do it through Terraform, but I found there was one or two things in terms of managing in the config. So just go click it once and everything is good.
So at this stage, we did 3 things: enable multi-factor authentication of the root user, enable Cost Explorer, enable cost optimization. That's manual. You cannot automate that. It's in the console. Click, click, click. Number 4 or 3 in your blog post, but number 4 in this podcast is to enable Identity Center.
Yes.
Identity Center, it's an identity provider, part of AWS, that allows to give you single sign-on access, so you can define your user, password. Why are you doing that? On which account? Are you doing that on every single account?
No.
Okay, I'll let you. I have 1,000 questions about that, but let's start.
I'll drop a link as well for Seb to put in the comments below for you for an article that I did on. Part of the reason is that with Identity Center, the difference between Identity Center and using IAM users.
That's one of my questions. Thank you.
Is that while you do set a password for both, you don't have API credentials that are long-lived. So what happens is when you configure your AWS CLI, which is my main use case for IAM users, you configure in a way that it tells it what the login URL is for your Identity Center, and then basically if you want to assume roles in different accounts, like you have set up, you still have that configuration, but it's just the names of them. So you don't even have to specify the account IDs. And then the big one is there are no credentials on your system. You don't have anything hard-coded in the the credentials file for the CLI. And what happens then is if you want to use the CLI, you basically go AWS SSO login. It pops up a browser window. You do your normal login as you would into the AWS console with Identity Center, and then it gets temporary credentials that it can use that are up to, I think, 12 hours is the maximum validity at this point, which initially was kind of like, I went like, this is annoying. Why do I have to log in every day? But if you take a step back and think about it, that's actually not that bad. I mean, if you're going to sit down for work, logging in once a day, it's normal. You have to log into your laptop. Yeah. And you log in that one time and then you're good to go for the day. And the benefit is no credential that you have to manage.
When you say there is no credentials on your laptop, there is no minimal credentials to allow you to do the assume role and the single sign-on things? How does it work?
There's nothing. Basically, in the config file, you specify they call it the portal access URL in the console. So, and you can customize that. So, for example, my one's an easy one to remember. I think it's AWS app.start or something like that.
And so the CLI redirects you to the browser. You authenticate in the browser. That generates the temporary credentials that the CLI can capture and use for the remaining of their validity. So it means in every single account you create an Identity Center user with a password.
No. See, this is where the fun part comes in. Identity Center, while you can create one in every account, you'll see the first time you start creating Identity Center, it asks you, do you want to do this for AWS organizations, or do you want to do this just for the single account? And the default recommended way is for organizations. So you'll see in that list of 10 things, where do I say enable AWS organizations? Because when you select the organization-enabled version of Identity Center, it goes and sets up your organization for you in the backend as well. And then you've got it across all of the accounts if you want to add future accounts. And then it just becomes a case of configuring Identity Center. Because it's got a slightly different permission model than what you are used to with IAM users and groups. IAM users, groups, and roles, where you've got, I think the top one is basically a group is the first one you create and give it a name like, let's say, admins or developers. Then you add users to those groups, and at that point they still don't have any permissions. Then the third step is you then create permission sets, which define these are the IAM policies that you can do things with. But those also are not yet linked to anything else. And then the fourth and final step is when you go, okay, now let's put this all together. And you tell Identity Center that for this account, so let's say the current account you logged in, or any, let's say, child accounts you have, this group, so let's say admins, can use this permission set on that account. So that's like I said, it's different, but it's a nice way to think about it, because now it's very simple to say, well, here's the IAM policy and it applies to the following accounts. You can just view it there when you create your setup. So it makes it a lot simpler to do the cross-account thing as well.
And you create your Identity Center in your top management account. This is where you define your user. Okay.
Yeah. At the moment, it's one of those, I would have liked to have that created in one of my other accounts, but the way it works is it needs to be in the topmost account in your AWS organization, just because of how the permission and security structure work, I think. I haven't dug in it too much, but the short version is, so that's now inside my top-level billing account. I prefer it not to be there, but on the other hand, I know that whoever logs in on that level doesn't have root access, and I do limit it, so I don't feel too bad about it.
And you define the identities in the AWS Identity Center, or you push the configuration to using a third-party identity center such as Okta or something else?
At the moment, I'm just using the standard setup where I rely on AWS with the identity pool to use it as is, but I definitely want to play around and look with how to hook that into other identity providers in future. Probably something that I use on a day-to-day basis, but I haven't figured out, because one of the things I have got in the backlog here for my home lab is setting up some kind of SSO sign-in to access some of the things that I run at home as well. So I do want to figure out what's the best way to do that as well. But once again, the bottom line is, for now, this is good enough. It's one place I need to log in.
Yeah, it's
one
simple.
login.
It's only one place. Everything is there. One of the things I really like about Identity Center users is that you can define your own MFA with also biometric stuff. So it can link to your Touch ID on the Mac keyboard, for example, or even passkey. So you can do use passkey not as a replacement for password, but as a second factor authentication, which is pretty cool. That's pretty much it in terms of manual things that you are configuring.
Yes.
Once you're there, this is where the fun starts.
Yes.
This is where automation starts.
Yes, but just to clarify, with Identity Center, the only thing we've done so far is we clicked enable and then OK. So we don't create our users or permission sets in there, because that's one of the main headaches I've had in the past, where if that's configured by hand, at some point you need to change it or fix something, and it's a headache. So now we're at a point where, okay, cool, we can start getting some Terraform going. Now, Terraform itself also has a chicken and egg situation where you have a state file that Terraform uses to store the resource it creates, and that it tracks what are the things it created on the last run, and then it compares what your config is with what exists in your AWS account or accounts, and that state file is something you want to store. So Terraform has a backend configuration where it can store that state file in multiple different places. So the one I normally use is a combination of Amazon S3 to store the file itself, and then a DynamoDB table to use for locking, because if you're running Terraform, Plan, or Apply, you don't want two different developers running that Apply at the same time with potentially different code. So what the DynamoDB table does, it literally just drops in a hash for the specific state file, and then if there's a lock on it, it can't actually proceed. So whoever gets there first creates the lock. Until they're done, the lock persists, and then it removes the lock again, and then the next person can go in the queue. But that means you need infrastructure resources for...
So you need an S3 bucket.
Yeah. And it's also not just the S3 bucket. You want the S3 bucket with versioning and with a policy on it in terms of who can access it. You want to make sure that it's encrypted. You want to make sure that it doesn't have public access, etc. So my thought here was, like, I've done that by hand so many times. I've tried different ways. Like, here's a little bash script to create it, or just use some Terraform one-off and don't store that state file. But then I started thinking about like, how can I make this easier? So what I came up with is a little module that we'll link as well, which consists of basically 2 lines. You can add more config if you want, but you specify what's the bucket name, and then I can't remember what the second one is. Oh, the region. There we go.
Ah, yeah.
And what that then does is, in the module, I have the configuration for the bucket and DynamoDB and the IAM role to access the state file resources. But what it also creates is that Terraform has a provider called local that allows you to create a local file. And how it works with the state backend is Terraform is one binary, so you need to tell it, where am I storing my state file? How do I access it? So that's things like, what's the bucket name? Is there any key prefix? What's the region? Is there a profile I need to use? Is there encryption, etc.? So the module generates that file. So you go in and create one file. I normally call it bootstrap. You add those 4 lines because it's basically the module definition, the 2 lines with the variables and then the closing curly brace. Then you say Terraform init, so it goes and looks at that. Okay, pulls down the modules and providers. Then you apply it. And as part of that apply, what it does is it generates the file that defines your backend storage as S3 with DynamoDB. And when you run Terraform init a second time, it sees, oh, my backend configuration has changed. I want to move my state file. And then you say yes, and then basically copies the state file into S3, and then going forward, it just uses that backend configuration. So bootstrapping is now as simple as 4 lines of code, which I feel is like, that's a nice, easy way to get started.
So there is no more bash shell script or Python. Just for you bootstrap Terraform with Terraform itself.
Yes.
That's pretty elegant as a solution. Just one question: why Terraform? Is there something you can do with Terraform you can't with CloudFormation, or maybe you were just used to it before you joined AWS many years ago?
Yeah, I mean, Terraform for me is like, that's a very long history because I started using Terraform when version 0.5, 0.6 came out. So I think that was in the order of 2013, 14-ish, I want to say. So CloudFormation had existed at that point. I had worked at a startup that basically had no infrastructure automation. So firstly, I started with a bunch of bash scripts. Then I started playing with CloudFormation, but we also had to manage things other than just AWS resources. So I then switched over to Ansible. It had some usage for other places, but then learned about Terraform and started using it. And because Terraform, the way it's built is that AWS is one provider. So if you want to manage other things, like for example, I used to manage Chef as well. So Chef was another provider, and we used GitHub to store our source code. So GitHub was a third provider. And what that allowed me to do is you can combine the things. So when managing users, for example, I would have Terraform set up to go and say, get me the information about the GitHub users that we have in our organization. Each GitHub user's got a public SSH key that I could then pull, and then I handed that over to the Chef provider. And then what happened is Chef would put that in a data bag, and then when a new EC2 instance is provisioned, because I then combine Chef with AWS, to EC2 instance spins up, it immediately gets bootstrapped with Chef. The Chef role applies, which also means putting the user there, and then basically Chef knows from that whole pipeline what are the SSH keys to put on the different EC2 instances based on the roles and configurations we had.
So you knew Terraform before?
Yes. Yeah, I knew it very well. I've been using it for years.
And that was your go-to, your go-to solution. From there on, the rest is made by software and deployment pipelines. It's no surprise, as you said at the beginning, you have a development background, DevOps background. So next thing is to set up a CI/CD, a pipeline to run more Terraform scripts.
Yes. Yeah. So the reason that, once again, is like, it's great having infrastructure as code, but you don't want to have random people running it on their laptop because there's no way to confirm that have they actually committed these config changes. Because let's say I'm working locally and I spin up a new EC2 instance and I create it, and by running Terraform apply, and you, Seb, are running another checked out version of the code, but you now want something else. When you run your one, it'll tell you, hey, in the state file, I see there's an EC2 instance, but you don't have it configured, so I'm going to go and delete it now because it's, there's been some infrastructure drift. So you can imagine how that's going to become a mess. So the way I set it up is you want 2 different build pipelines. The one is to do up to Terraform plan. So you do Terraform format, init, validate, and plan, so you can see what is going to be changed. And then you want one that actually applies those changes. And the way I set it up is any commit or push to the main branch is the one that goes through the apply, and then you put a branch protection on main, so you can't push directly to main, which means the only way to get content or changes in is via pull request. So then the second build job is the one that run up to apply, and it takes the output of the plan, or if there's an error, and actually comments on the PR with that detail. in terms of what the change is. So you can do proper reviewing of, hey, this is the new infrastructure change. Let's see what changes. Do we want to do it and roll it out? And then you just say yes or no. And if you say yes, merge the PR and off it goes, and basically goes and applies it.
So what are the tools you're using for both for the source and for the pipeline itself? The source, it's some kind of GitHub, GitLab.
Yeah. At the moment
else?
it's for GitHub. I set it up for GitHub. Just my main use case is for GitHub, but there's nothing stopping you from using GitLab or one of the other ones. But Buckets, anyone that's basically supported by the AWS side of things with code build. So code build, I think, does all of those, plus so custom Git servers.
So that's the next one. Is my next question was what was the pipeline itself? So it's AWS code build.
Yeah, it's AWS code build. I have got an example as well for how to use GitHub actions. That one gets a little bit more tricky in the sense because you have to set up the OpenID Connect credentials between GitHub and your AWS account to be able to interact with them, because what you don't want in a build pipeline is hardcode credentials, because that's the main thing I'm trying to do. Is I'm getting to a point where I shouldn't have any credentials anywhere that I have to deal with. So the one module that I used in the blog post is also, I think it's about 4 or 5 lines, and that'll set up your CI/CD pipeline for you to get everything going. And once you have that in place, it means now you can make changes to everything. So I then have, as a last semi-manual step, is creating a pull request to go set up my Identity Center users, groups, and access to the accounts. And then once that one is moved through the pipeline, you can basically say, okay, cool, now let's log out of the console with the root user, and I'm now done. And all of this is done with CloudTrail, because I specifically said I don't want to have to set up a temporary IAM user or use the root user locally or anything like that, because CloudTrail uses whichever user you're logged in with. So it's a case of just quickly going through, getting things set up. It does mean you have to figure out, how do I want to get the code, the Terraform code that I created? Yeah.
CloudTrail.
So my approach there is, you've got 2 options. You can either say, well, let's copy and paste that code somewhere by hand, or let's create a SSH key and use that with GitHub, add the key temporarily, and then from there just quickly push the code back into my Git repo, so I know that it's there and I don't lose it, and I can check that the pipeline works. And then afterwards, what I do is, you can, with CloudTrail, just say delete the instance, and it basically removes any config on there, and then also remove it on the GitHub side, which means that whatever was in there is now gone and deleted, and I'm not going to use the root user again, so we're all good.
So I imagine on the GitHub side, you have a collection of templates or Terraform files to run through your pipelines. What do you need to change manually in this file to bootstrap a new account? I guess you need to enter things like account IDs and other details. Not even that?
No. So how it works is, with the bootstrapping for, let's say I've got a brand new root account. I can create a new Terraform file, and then all I need to do is I need to use a module, because the module I created is published on GitHub. It's one of the ways you can actually get access to a module. So you give it the name of the module that you want to use. Then you've got a line saying where the source code is for it, which is that Git location. And then you specify what is the S3 bucket and what is the region you want to deploy.
So that's the bootstrap. And once this is done, all the other Terraform files are totally generic and they can run through your pipelines. What are the typical...
Not quite. The thing is, there's a second module, because I went down the module route. So there's a second module you add to add your pipeline. So that one is also about like 5 or 6 lines. So once you've got those 2 in place and you've run and applied them once, then you can make just get that code that you just used into that repo somewhere, and then you're good to go. And you can just use the repo going forward.
What are the other, so if I count well, we are at number 6 in our checklist. So the rest, I understand, it's Terraform
all the way.
Template? How do we call them in Terraform? For CloudFormation,
modules.
It's template?
Yeah, it's a combination with Terraform modules and defining templates. The resources,
And you're running always the same for the 4 remaining steps. What are these?
So the first one is enabling AWS CloudTrail.
Very important.
Yes, trust me, that one has saved my bacon so many times. It's especially when I was trying to figure out the OpenID Connect provider between GitHub and with AWS, because you have to be very specific on what is the calling identity from the GitHub side into AWS, because the examples that I saw basically said if the request is coming from this GitHub repository and organization, allow the pipeline to run, which is not what I wanted, because I want to make sure that if it's a PR, you cannot touch infrastructure code or infrastructure to make changes. You can only read it to validate the Terraform. So basically, I spent a lot of time back and forth, because CloudTrail basically shows you all the API calls and actions taken on your AWS account. So I could see exactly the call coming in from GitHub. Oh, it uses this specific reference from the repo. So it's /refs/ PR/1 and things like that. So you can get very fine grade detail of exactly what's going on in your account.
Turning on CloudTrail, it's just a check on, or you need to specify other details like what is the S3 bucket to receive the trails and encryption.
You have to specify the S3 bucket as well in where to do it, and also then a bucket policy if you want to go cross-account. That's where things get a little bit interesting because you can enable CloudTrail to monitor any of the child accounts inside your AWS organization and then have them all logged to the same single bucket, which you then use the bucket policy to enable that. And for the bucket itself, you want the usual things with versioning and encryption at rest. So there's a bit there, but once again, I put that all into a module as well, just to enable it.
Where do you store these logs? Do you bring back up everything to a logging account, or each account has its own
At the moment, that's in the main account, just because of the way that with organizations, it's easier to set it up as in the topmost node. So my top-level billing account is starting to get a little bit more busy now, but it's all with the common things that are across all the accounts.
So that was number 7, CloudTrail. Number 8?
Yes, a budget.
Budget important.
Yes. So this is one of the things we often hear from folks is like they start playing around, and with any cloud thing, if you basically spin up resources and you don't pay attention, you can run up costs. Like my lesson about this was I went to an AWS workshop, I want to say 2012. It was just when autoscaling groups had rolled out, and it was CLI only. There was no UI. So I went off and I worked on the workshop, played around with it afterwards and set something up, thought this is cool, and then went in and said, okay, cool, I'm done. Let me just delete the EC2 instance and forget about it. End of the month, I get a bill. It's luckily not big because I was using, I think, T2 micros at that point, but I'm like, what? So I go back into the account, I see there's an EC2 instance, and I'm like, okay, that's weird. Delete it by hand again because I didn't use automation
then they
yet.
Came back.
The next month it's back again. I'm like, what's going on here? And that's how I learned about, the automation and the also needing to keep an eye on what it is. So what the budget step basically does is two things. Firstly, it says, what is my budget? So I set it up to default to $20, or I think 10. Can't remember. It's 10 or 20. And then on top of the budget, I set a billing alert that tells me if my projected usage for the month hits 75% of that, because you want to have a bit of a buffer before you get to whatever your budget is. Yeah. And then what will happen is it'll send me a mail saying, hey, listen, you've reached your budget limit, or you're approaching your budget that you've set. Go take some action and sort things out. And there's a whole bunch of things you can do from that, like automate it with various things you want to do, like automatically shut things down, etc. But that's up to how you want to automate it and build it.
And this is per account. It's not something you can manage globally on the main account.
This is in the main account at the moment. I need to double check if I can go granular enough to set a budget per child account still. But that's something I still want to do. At the moment, I'm just looking at the overall budget.
So that rule number 8, set up a budget alert. It's something you do only once for the master account. You don't need to change it for every single
not at the moment. I'm still digging into it. I probably want to have that set up for every single child account as well, but I just need to go double check how you would want to do this and manage it with multiple accounts, because that's always where the fun comes in, is like just because you can do it in every account doesn't mean you should.
And I guess it's the same for rule number 9, which is centrally managing a user. It's something you do once in your root account in Identity Center. We talked about that already. What are the types of user and groups you're defining for your own usage?
So typically for me, my own personal accounts, I keep it simple. It's just me. There's no one else touching these. So I've got a single admin account that has admin access to all of the different ones. And it's because, like I said, it's a one-off. It's just me. I don't envision anybody ever working with these, so that's perfectly fine. But when I was working as a consultant with startups, typically we would split these into, there's the system admin folks that have the full access to everywhere that have to be able to do. Then there's the developer access account. Now, for that, typically we would give them in the developer AWS account, like admin-ish level access, not full admin, because we don't want them, for example, to go delete DNS entries or things like that. And then as they progressively get closer to production, the amount of access they have to the AWS account gets lower and lower till they hit production, which is usually read-only. And that comes back to the whole pipeline thing, because what that would enable them to do is go use the Terraform pipeline to make changes to infrastructure, make sure that it's working on dev the way we expect it to. And then once it's ready, it's the pull request, and then that pull request moves through the different environments. And they can go verify the changes because they have read-only access, but they can't go and change anything in production.
That's the best practice. Only the pipeline has security credentials or roles that allows it to create or to change resource in the production account, and humans cannot do that. But that reveals also the importance of securing your pipeline and the GitHub, which is the trigger of the pipeline to not inject garbage into the pipeline.
Exactly. Yeah, it's there's no way around it. I mean, at some point, there has to be something like, usually it's the build pipeline that needs to have almost full access to be able to create everything. But there are ways to manage at least that risk a bit better.
And the last, local access, setting up your CLI.
That one is because now that I've got this glorious pipeline running in the cloud and I can do pull requests and all that, it's kind of difficult to send a pull request if I can't check what I'm just writing now is actually working. So that's where the different roles come in. So what that means is setting up my local AWS CLI, which is as simple as, I think it's AWS SSO configure. And then basically it asks you what's the starting URL, and then it asks you which of the accounts, because once you've logged in as part of that flow, it can actually see, okay, your user is allowed to access all these different accounts, and let's add them to the config and set them up. And then once you have that going, now you can do the local development and then send the pull requests and be happy.
10 things to do on a new account. 2 or 3 are something to do only once on your organization account, but the rest can be applied to all the accounts within your organization. The link to the blog post is obviously in the notes of this episode. You just scroll down, and in the blog post you have the links to the GitHub. Is it correct? Did you link?
It's in the blog post, looks in it, but it's simple. It's build on AWS and then Terraform samples. Everything is in there.
Oh yes, and so you have all these Terraform scripts and everything we talk about to set up your account. Thank you, Cobus, for sharing your experience with us, with the listeners of the AWS Developers Podcast. Thank you for having listened to this episode until the end. See you next week in your podcast application. But now, go build.